Now that you have done your Desmos discovery, we're going to formalize that a little bit. So this is your absolute value equation. The biggest thing that I tried to get across in that Desmos activity was this x minus h, that format. When your h value is positive, it will go to the right, so horizontal. Because x minus, if my value is positive 3, that's what it's going to look like in the absolute value. So the parent function is y equals absolute value of x. Our vertex is going to be hk. So this is moving it right, left. This is moving it up, down. So that's where your vertex is going to be. There's going to be an axis of symmetry at x equals h. So when we have that v, x equals whatever that x coordinate of the vertex is. It opens up if a is positive and down if a is negative. So when it's opening down, that is called a reflection. When the graph is, or when absolute value of a is less than 1, what that means is that a is between 1 and negative 1. So it's a fraction less than 1. Then it's going to be wider than the parent function, and we're going to call that a vertical shrink. Because if you think about it, if I'm pushing down on, like if this was an open book, if I push down on the book, it's going to get wider. So it's called a vertical shrink, and then you would say factor of whatever that a value is. And you'll have that always be positive. If the graph is narrower, then we call this a vertical stretch. So if you think about, like, if this is a rubber band and I pull up on that graph, so now I'm pulling up, it's going to get narrower. And so that would be factor of, or you could just say vertical stretch of whatever that a value is. And that a is greater than 1. That means that the absolute value, so it could be a is greater than 1 or a is less than negative 1. Okay, so let's look at an example here. So when we had a vertical stretch or shrink by a factor of that a value, that's going to determine what the slope of those lines are, because the parent function has just got a slope of 1 and negative 1. So the first thing we're going to do is state the vertex. So again, remember that the absolute value equation is y equals a absolute value of x minus h plus k. So the vertex is our hk. So in this equation, I have a x plus 3. So up here, that's minus h. So in order to make it a plus sign, that means that it would have to be negative. So x minus negative 3 becomes x plus 3. So anytime you see that plus sign there, you're thinking opposite. It's going to be a negative 3 going to the left. And then out here we have the plus k, so then that means that this is a minus 4 is going to be a negative 4 for the vertex. Then you are going to describe your transformations. The first thing you're going to do is decide if there is a reflection. So in order to tell if there is a reflection, if we look back here, there's a reflection if a is less than 0. It's going to open up if a is greater than 0. So that a value is that one out front. So when we look at this, a is negative 1. So that is telling me that I'm going to have a reflection. So I have a reflection, and you have to tell me across what line. So it's going to be across the x axis. And there's other lines you can reflect it across, but so like my parent function would look like this. So it would be like this. And if I am doing my reflection first, now it's going to be opening down. Okay. All right. So then I want to say if there's any stretch or shrink. That A value there's no other number there besides it's a -1. So there is no stretch or shrink. That's going to be my slope. And my slope is going to be plus and minus 1, depends on which side of the line you are on. And then since my vertex has moved -3, -4, that's also going to tell me what my translation is. So I'm going to translate left 3 and down 4, because that's where my vertex is going to move. If I move left 3 and down 4, that's going to be my vertex. That's also telling me what my translation is, because everything in the graph is going to move. Okay, so now I'm going to graph the two sides of the lines, and since the slope is 1 and -1, we just have to remember it's opening down. This tells me also opens down. Okay, so I'm going to make my slope of 1 and -1, down 1 over 1, down 1 over 1. So this is, my absolute value function. Now I am going to find the domain and range. Okay, so remember domain is all of our x values. Okay, so everything that I can plug in. If this is going on forever here and forever there, there's nothing missing in between. So you're going to include all of the x values. And so remember interval notation now. For everything, we're going to start at -infinity, that's over here, -infinity, and we're going to go all the way to +infinity. So that's the whole real number line. So I start here, and I'm going to be able to cover everything on that number line. Okay, the range, I'll do this a different color. The range, I'm going to start always at the bottom and move up. So at the bottom, I'm hitting these arrows. So it's going down forever. And then I'm going all the way up, but I'm going to stop. There's no y values up here. There's no, the graph is not going to go up there. So the range is not all reals. Okay, so when I look at that, I'm starting at -infinity. And I'm going up to, this is that point, -3, -4. So the y value is -4. Since I am including that y value, I'm going to have a bracket. And that is my first example. Okay, so let's try that again. We're going to do the same thing. I would pause the video here and try it on your own first. Okay, so we're going to state the vertex. So remember it's y equals a, absolute value of x minus h plus k. So the vertex is that h and k. So it's x minus h. So this is 2 and 1. So remember that inside those absolute value bars, we're kind of thinking that as the opposite of what you might think, because this is a +2 because the original equation is x minus h. So that's our vertex. That's also going to tell us what our translations are, just so you know. Okay, so our first thing we're going to ask is there a reflection? Because I need to take care of that first, because these are acting as my instructions for what to do. And if I reflect after I've moved it, then it messes everything up. So like if I on this last one, if I moved it down to -3, -4, and then I reflected over the x-axis, it would move the vertex up here, okay? So I want to do my reflection first. So when I'm looking at this, my A value is positive, so there is no reflection. So now I can do anything in any order. Since my A value is a 3, that means I am going to have a vertical stretch or shrink. Okay, so now to remember, vertical stretch happens, if we look back over here, vertical stretch happens when the A is greater than 1 or less than -1, okay? And it's wider if the absolute value of A is less than 1. So it's a vertical stretch of 3 because my A value is 3 and 3 is greater than 1. So that's why it's a stretch. And then I am going to translate. And I'm going to go right 2 and up 1. That's where my vertex moves, so that's where every point has to move. So right 2 and up 1. Now, since there was no reflection, this is positive. That's going to open up. It's also going to tell us what our slope is going to be on both sides. So it's opening up, and it's a slope of 3. So rise over run is our slope. Rise over run. So I'm going to go up 3 and over 1. Up 3, over 1. And on the other side, up 3 over 1, up 3 over 1. So you're going to notice that that is narrower. So that's why it's a stretch of 3. So that's something you can check after you've graphed it. Make sure you've got that stretch. And then the last thing is we are going to do our domain and our range. Okay, so again, domain is our x values. Now I'm going across my x values and I am going to be able to hit everything in those x values because that is going on forever in both directions. So again, our domain is -infinity to infinity. We always put parentheses next to infinity because infinity is not really a number, it's a concept. And then our range, I'm going to look at the bottom of the graph. So when I start, the very first thing I hit is right here, and then I go up, okay? I don't have any y values down here. So I'm going from the bottom to the top. This point right here is 2, 1. So that's my y value that I start at, and then I go all the way up. So least to greatest, bottom to top. Since I am including 1, I have a bracket here, and then I go to infinity. So that's my domain and range. We have one more example, but I'm going to stop the video here.